Dr. Chandra Wickramasinghe, the eminent Sri Lankan-British astronomer, astrobiologist, and mathematician, has been tracking the early analysis of the asteroid Bennu by NASA as pairing building blocks of life, such as water and carbon, with some justifiable self satisfied amusement. That cosmic objects such as Bennu carry building blocks of life is something he theorized in 1974 with the iconic physicist Fred Hoyle and had worked on the idea even earlier in the 1960s. To the 84 years old Dr. Wickramasinghe, such findings have never come as a surprise. As a pioneer of the science of astrobiology, he has always pointed out, along with Fred Hoyle, that life is cosmic. To get a better sense of how he views rock samples such as from Bennu being brought back to Earth, Mayank Chhaya Reports spoke to Dr. Wickramasinghe. Welcome to Mayank Chhaya Reports, Professor. It's always a great pleasure to have you on.
Thank you for having me. Thank you for letting me return to your fantastic set of interviews that you always do.
Oh, how nice of you. It's always a great place. It's riveting to talk to you. Two key features stand out from the preliminary analysis of the asteroid Bennu sample by NASA. One is hydrated rocks, meaning there is water locked inside, and then the other is very high carbon, nearly 5%, I'm told. What do these findings tell you?
I think the news reporting of this story is more interesting than the news itself, because the fact that there's a lot of hype over a discovery that is not that great in terms of novelty or there's anything new that's been discovered. Well, scarcely, I think a year or two ago, there was a similar asteroid called Ryugu that was samples brought back, and very similar statements were made by them. And the point is that both Ryugu and Bennu and this new object Bennu are, I think, they are residues of cometary objects that were once laden with volatiles, maybe mini comets, and the volatiles have evaporated over many circuits around the sun, and you're left with the rubble, the sort of core of these objects that we are collecting in little bits, tiny bits, have been brought back to Earth. So to find that there's evidence of water is not a big issue, because we know that comets are almost sort of 70% water or more than that. And we also know that from essentially life-related molecules, not just carbon, as they are claiming, carbon that might have been connected with the sort of organic molecules, but actual organic molecules, biochemicals, have been discovered and reported over, in terms of sample returns, in meteorites, in carbonaceous meteorites, for over 2 or 3 decades, right? I think about 15, 20 years ago, there was the report that the Murchison meteorite, which is a meteorite that fell in Australia, in Murchison, Australia in 1969, this meteorite had nuclear bases within the structures, within the carbonaceous structures, right? So this was reported, and the issue of whether these are this stuff was contaminated or not, contaminants or not, had been discussed. But I think the general consensus is that organic molecules are continually being brought in by carbonaceous meteorites, right? They keep falling onto the Earth. So in that sense, it's not new. They discovered that there's a lot of carbon associated with Bennu, and there had been water associated with the original structure that was Bennu. And as I said, a very similar story had been revealed for another bit of a carbonaceous asteroid that was brought back, which was this is Ryugu, but I think Bennu is what we're talking about now, right? So both of these objects, Bennu and Ryugu, are somewhat similar, and this I think to me is not new. But
Yeah.
the hype and the claim that this essentially means that the building blocks of life are external to the Earth and are brought down to the Earth to sort of link up into simple living systems. That's again not new. I mean, we've been talking about
Right.
that for, as you said, from the 1970s. We've written papers that I think I've got copies of the books in which they were published, but a lot of the original papers were published in Nature in the 1970s, when we said there was evidence for the building blocks of life everywhere in the galaxy, and these were published and commented on, and so this is the one of the books in which we collected the living comets that
Oh, I see. Yeah, I can see that. Yeah.
Fred Hoyle and I
Okay.
wrote in the early 1970s, and then there was a whole series of papers, of scientific papers, that expanded on that theme. So that's certainly the idea of building blocks of life in deep space, and essentially coming from comets is not new. It's been extensively discussed by lots of people, but primarily by the late Sir Fred Hoyle and myself in, as I said, a very long series of papers starting from 1974.
Right.
Of course, we started off with saying that building blocks of life are everywhere in the galaxy, not just in Bennu, but in Aurigu, but everywhere in interstellar space, right? We claimed
Right.
that there was evidence from radio astronomy, from millimeter wave astronomy, from infrared astronomy that there was huge amounts of these organics that are in deep space, right? Not just in the solar system. Bennu and Rigu are solar system, small solar system objects, but we were looking much, much further into space, and we found these evidence for sort of spectral evidence,
Right.
signatures of molecules that we regarded as being related to biology. So the first step that we did was to say that these molecules must be delivered to the Earth now, as well as in the very early history of the Earth. And we made these same statements that these guys are making now, that the molecules were perhaps delivered to the Earth, and then the old story of the spontaneous generation of life took place here on our planet, right? That was
Correct.
our first step in the mid 1970s. But then we began to analyze the sort of probability of this happening, of the building blocks of life coming, and then from the building blocks to get to the most primitive living system. It didn't take us very long to conclude that the standard story was just absolutely, that had no validity at all. The probability of building blocks turning into the simplest living system is super astronomically small, if you can
Right.
describe it as in that way. So there was no way. It was a miracle. If that happened, it was a miracle that happened on the Earth. Okay. So we then made the statement, or we argued and found compelling evidence, I think, for bacterial material being widespread in the galaxy, right? Not just again outside, this is again outside our planetary system, outside our solar system. We looked at very, very distant stars, and we found the signature of a bacterium in that the light that came through all this stuff and reached the Earth. So at that point, we then said, hold it, is it really only the building blocks of life that are everywhere? Or is life itself, is the complex assortment, arrangement of living molecules into bacteria essentially universal, essentially cosmic? And then we had, of course, to assess this and think rationally about this. And then we came to the conclusion that that's the only rational way to look at the huge flood of data that we were getting in the 1970s to say that life itself is cosmic. So this was the turning point, and this was the stage at which people said, no, this is a departure from long established ideas of spontaneous generation. Now, I think I mentioned earlier in one of my interviews that spontaneous generation was almost written in stone in European culture. It
Right.
was an Aristotelian statement that Aristotle made in the 3rd century of the Common Era, before the Common Era, and people held very firmly to that. And even when the evidence in the late 19th century, evidence from Louis Pasteur was very, very strong against spontaneous generation, people still kept holding on to that. And I think it's happening even now in the 20th century, in the 21st century, in the age of AI, in the age of sort of molecular biology. I think I think it is disgraceful that scientists do not stop and think, how improbable is it for life to start given these so-called building blocks? You can put all the building blocks that you like into the oceans, from Rigu, from Bennu, from comets or whatever.
Right.
But unless there is life itself that can take those building blocks and replicate it, then you can just forget about it. The building blocks will remain building blocks. So that's the position that I hold on this, and the deeply entrenched view has to be somehow got rid of, otherwise science is in a stalemate.
Right.
I mean, there are a few other related discoveries in the last couple of months. I think your listeners might be interested in recounting. I think it's about 2 months ago that the James Webb Telescope found a molecule in a very distant, what's called an exoplanet, right? A planet outside
Right.
our solar system, 200 light years away. Right? This is the planet that was explored, and they found that the atmosphere of that planet had a molecule called methyl disulfide,
Right.
plus carbon dioxide and methane. Now, the investigators have, I think there was another huge news flash on this. The investigators say that this means most likely that there is life on this distant exoplanet, and that then, therefore, life must arise just spontaneously, easily. So one miracle on the earth has been multiplied by a factor 2,
Right.
and then a miracle will turn up, and you'd have an infinity of miracles superposed upon another. So the sooner people realize and act and think rationally, I think the better for humanity and the better for science. It is becoming increasingly clear now that not only the building blocks of life are everywhere, but clear evidence for life is to be found in other planets, and the connectivity of all of these life systems has to be taken very seriously because of the probability arguments that I just discussed.
Right. You spoke of miracles. By their very nature, they are scarce. So if they happen that frequently, that means they are no longer miracles, right?
They are no longer miracles. It means that there is a pathway that either
Right.
scientists have not seen, or that we have found difficult to track down in some sense. But I think neither of those options are rational options. The rational option is the one that I mentioned earlier, to say that life is truly a cosmic phenomenon, and it just takes root whenever living particles like bacteria and viruses that can live independently and replicate independently, when they arrive onto the
Right.
surfaces of planets. So
How do
that's
you sorry to interrupt. How do you get around the problem of the definition of life, life that we understand as human beings on Earth, and what life might be, say, on the planet that we just mentioned, exoplanet, 200 light years away? Uh,
I,
has that question been resolved at all?
well, I think if my point of view, like the point of view that we have panspermia, or connection of life across the whole galaxy, across the whole universe, is correct, then all life has to have a similarity, underlying similarity, So the life on this exoplanet that I talked about would be no different from, say, the life on in two different parts of the Earth, for instance, from maybe from one hemisphere to the other. So the same sort of basic structures would be there. They may be assembled in different ways, and they may be slightly different one from another, but the overall patterns of life would be replicated. And I would take any bet that we would have people like you and me talking on these other planets, looking very similar to you and to me, and discussing these great issues of, are we alone in the cosmos? Is there life elsewhere outside of the little exoplanet? And so on. These questions are going to be probably universal questions, and so that's I
But
think.
this is presuming that it's carbon based elsewhere, right?
Yeah, I mean, carbon is everywhere, isn't it? Carbon, we know
Right.
that carbon is made in stars, that it is a very abundant element. We know that carbon is extremely abundant in interstellar space, right? We mentioned organic molecules in space this first discovered in the 1970s. Uh, the original discovery of organics in space sort of goes back to a paper that Fred Hoyle and I wrote in the monthly notices of the Royal Astronomical Society, in which we argued that the cosmic dust is mainly made of carbon. That's in 1962. By
Right.
1974, we had been working on it in that sort of decade. And 1974, we came to the conclusion that not just carbon, that the cosmic dust had to be of a complex, organic, polymeric uh, structure, that it had to be polymers, long chains of carbonaceous molecules. We thought first of polyformaldehyde and then of chains that resembled biomolecules. And in slow stages, I mean, not all at once, but in slow stages, we came to the uncomfortable for us. It was because it was very, uh, it caused, created many enemies, but uncomfortably, we decided that we had to admit that life itself must be maybe everywhere in the form of bacteria and viruses. And these would be the components of which all life, not just on Earth, but all life in the universe would be made of. So just imagine a gigantic child's jigsaw puzzle, right? With the components of life, components of all life, just thrown into space, just thrown around and falling on planets where there's water, so-called habitable planets, and these pieces get together and make the patterns of life that are seen on the Earth. And the patterns, therefore, would be, because the pieces are the same, the patterns elsewhere would be very similar.
I see. I want to pick your brain on the question of how the role that gravity of a particular celestial body would play in terms of the evolution of life. I'm presuming that life on an exoplanet with much different gravity than here would play out very differently, wouldn't it?
Yeah, it would play out very differently. I mean, just if the planet had very little gravity, I think we would have people, I mean, creatures like insects rather than humans walking on the surface of a planet. We'd have flying creatures flying through an atmosphere. For instance, they would be the dominant species would be aerial uh, species that took to the air. And on a planet that had much greater gravity than Earth, maybe the shapes of the individual larger animals would be different. Perhaps there would be adaptation, but the basic genetic structures that would be involved in fitting into these structures would be universal and would be the same.
How do you explain the fact that the moon, which is exactly in the same vicinity as we are in terms of its being conducive to life, does not have life?
Well, I think that is a moot question, because we have now had a couple of missions to the moon. There's water on the moon. There's very little atmosphere, right? This moon is a very small object. It doesn't hold an atmosphere, so there's no oxygen on the surface like that larger creatures could breathe. But if there is water, if there is ice beneath which there is liquid water, I bet there would be life. I think there would be no question that there would be life. I've written about it, my colleagues and I have written about this, and ahead of the latest mission to the moon, which is Chandrayaan the three, that landed successfully on the south pole of the moon only about 2 months ago, right? The hope is that these probes will discover water, for sure, water ice, and if they can go beneath the water ice crust, they would have life. There's no question about the microbial life, very similar to the microbial life on the Earth, because after all, the Earth and the Moon are very, very closely. They are almost next door neighbors, isn't it? So
Right.
whatever life can survive on the Moon, if stuff is exchanged between the Earth and the Moon, even the stuff on the Earth should have reached the Moon and found places where they can thrive. So I think that's going to be the next important disclosure that perhaps you would want me to talk about if I live long enough, right? And
Yeah.
of course, there's also the missions that are going to the moons of Jupiter. And there's one moon of Jupiter that has always been really very, very interesting to me, and that is a moon called Europa.
Right.
Europa is an icy crust. It's a frozen world. There's no atmosphere. There's not much of an atmosphere, and the crust is cracked all over the place with red pigment evidently oozing out of the cracks. The cracks are sort of marked with a red coloration. And I would bet you that when they go there and drill through the ice, they would find lots of living creatures underneath that ice. My friend Arthur C. Clarke, whom I knew rather well, he used to say that they would find dolphins, intelligent dolphins, under the ices of Europa. Well, I don't go as far as that, but I think there's no question that there would be life discovered on the planet Europa, and maybe on other Jovian planets also within the next decade, because this is the time scale that's being talked about for the JUICE mission, for the European mission went, and then there's another American mission that is also going there, and that is what is going to happen. I think there's no question that more and more places in the solar system would be found to have life. I mean, Rigel and Bennu are just the start of the game. They found evidence that they are interpreting as building blocks, but I think much more likely these are comets that have been essentially dried out after millions and millions of transits around the sun, and they have the bits and pieces, the dried bits and pieces and fragments of bacteria. But if you go to an actual comet and drill in deep into it, you would find life in a viable state. I think there's no question life would be discovered on a comet before long, for sure.
Just last couple of things. One is, do you think the debate that life is cosmic should end now? In your judgment, it is cosmic, although we haven't been able to prove it empirically yet. But all signs point to that fact. Do you think that should be the conclusion at this stage?
I think that should be the rational conclusion at this stage. The only fact that is holding it back is that there's been huge amounts of money devoted or expended on the contrary point of view, right? The projects, science projects and space projects and so on, directed towards finding only the building blocks of life, not life itself. And the long entrenched view from Aristotle onwards that life occurs easily, spontaneously, whenever you get the little bits of chemicals supplied to them, the so-called building blocks and water and an environment in which they're supposed to get together and make life. I mean, that's just a fairy story, but that's the story that sort of continues. That's really, it's the whole thing is really crazy. Last year, I think Rigu had this other carbonaceous asteroid that was sampled, claimed that there was something like, what is it called, uh, a component of RNA discovered in it. I think uracil was discovered. Again, this was considered to be just a building block of life, and that was it, and that no further investigation proceeds once they say it's just a building block of life. So I think we are stuck in a groove until we really get out of the groove. We are going to be inventing all kinds of hypotheses to defend the existing and the ongoing barrage of information that is going in the opposite direction, pointing to life being a truly cosmic phenomenon.
On a somewhat unrelated subject, how did you view the debate over Oumuamua, the first interstellar object? Since you mentioned your friend Arthur C. Clarke, he had a remarkable book, Rendezvous with Rama, which was eerily similar to what Oumuamua was.
Yeah,
The
well, yeah, yeah. I would have liked to think that that was an intelligently directed spaceship that came from outside the solar system. I toyed with that idea for a while, and I know my colleague, a colleague in Harvard, still believes that. But I think the evidence, the astronomical evidence, is against it. I think it is more likely to be a natural comet that came in and went out of the solar system, inner solar system. I mean, we've tried to analyze all the data and explore the different hypotheses in several publications over the last 5 years. And my conclusion, reluctantly, is to say that this was probably not a spaceship as much as I would like it to be, but a comet from deep space.
Yeah, Professor Avi Loeb, whom I interviewed for this earlier, he still, the gentleman that
Oh,
you're talking about at Harvard,
yeah.
I think
He
he
meant
still maintains that it could have been a light sail of some sort.
he says it's lighter. Yeah,
Yeah,
I don't know. I would like to agree with him. I think I would really dearly like to agree with him, but I cannot find the evidence that is needed to support that position. It is something that is certainly possible, given that life is so universal. And according to my point of view, there's no question that life, like the life that we see on the Earth, the intelligence that we see on the Earth in humans and maybe in other animals, that this is universal. Intelligence is not unique to the Earth or to Earth life. So there will be intelligent life forms outside. Indeed, I think that to regard ourselves, human intelligence, as the peak of, as a culmination of intelligence is really arrogant. I think we
it
are
is.
perhaps,
Yeah,
I think we
yeah.
are perhaps at the bottom of the league. There must be.
Uh, right. Before I let you go, if you were to advise NASA at this stage, in the specific context of Bennu and objects like this, what do you think they should be looking for beyond building blocks?
I think they should keep an open mind, not reject the possibility that life is truly cosmic. They should regard the discovery of life on Bennu or on any other object, astronomical object, as being perfectly okay to admit. I mean, this is something that they're resisting. At every turn, they're resisting the possibility that there is a living system outside of the Earth. They would like to see everything as the components of life that haven't really got together and made life, but the components are all there. And if the components are all there, if the conditions are very similar to the Earth, I think they should entertain the possibility that life itself is everywhere, and ditch the religious obstacles that face them. I think that's really a major problem. It's not admitted that it's a religious obstacle, but it's a cultural obstacle. Scientific tradition intervenes and prevents the sort of establishment science bodies around the world to try to hold back from the hypothesis or from the idea that that life is universal. I think we need to come to grips with facts objectively. Don't turn away from something that you think is irreligious or not within the scope of established philosophical principles. Just chase the facts, follow the facts, and see where the facts take you. I think the facts should dictate the future of the world. I mean, even in terms of human relationships, in terms of international relationships, I think the sooner we grapple with facts rather than with ideologies, the better for humanity and better for the world.